it back one time. 3.2. Okay. Divide that by 100. 0.32. By 1,000, it would be 0.032. We'd have to add a 0 because we don't have three numbers there. Okay? And that's something that's simple. Should be fairly easy to remember, because if you think of a number line, you know that on a number line, numbers get bigger going that way. So it makes sense that if we want to multiply, when you multiply, things get bigger. It makes sense that you're going to go to the right. On a number line, the numbers get smaller going this way. So it should make sense that you're going to go to the left if you want to make the number smaller, and when you divide a number, the number gets smaller. So that's how you should be able to remember that, okay? Any fraction can be changed to a decimal or a percent. Any percent can be changed to a fraction or a decimal. Any decimal can be changed to a fraction or a percent. They're all the same. They all represent numbers smaller than 1, smaller than a whole. You can express a half in lots of ways. I can say half the class didn't come tonight. I can say 5/10 of the class didn't come tonight. I can say 50% of the class didn't come tonight. That's all the same thing, right? All the same thing. And you still don't know how many people didn't come, do you? Right? What do I have to know how many didn't come when I say half of the people didn't come tonight? What would I need to know? How many people are in the whole, right? To know how many are in the half, you have to know how many are in the whole. The same thing. If 5/10 of the people are not here, I need to know what 10/10 of the people are, because you know that 10/10 is the whole. Okay? If I want to know 50% of the people, if I want to know how many people that is, I have to know what's 100% of the people. All of these equal one whole. When you say 100%, that doesn't mean 100 things, right? If there are 2 people in the class and both of them are here, 100% of the people are here. That's just 2 people. 100% just means that if the whole was broken into 100 pieces, all 100 of them were there. Okay? Just to understand. So anytime we talk about percent, we're talking about out of 100. But we just talked about the fact that when we want to use percent, there's not always 100 things in the whole. There are 4, 7, 9 students here. So 100% of you is 9, right? Right? All of you are 9. So, in my case, there's not 100. There's only 9 in my whole. And if all 9 of you are here, then that's 100%. Equals a whole, you see. So, when you say he got 70% on the test, you are saying that if there were 100 questions on the test, he would have gotten 70 of them right. That's what you're saying. But maybe there are only 20 questions on your test. That's not 20%. I have to figure out what happens with percent is that you're going to figure out how many out of 20 is the same as 70 out of 100. Because then you can call it 70% because it's the same. Same thing. It's not out of 100, but I'm saying if you got these many right in 20 questions, you should get 70 right out of 100. Now, you know that's not always true. Maybe the first 20 were easy, or easy for you. Maybe you wouldn't get 70 right if there had been 100. But we don't always want to give a test with 100 questions on it. And we still want to say percent, because you want to be able to compare. You know, if you got 3 out of 7 and he got 6 out of 7, you know, well, you know that's 3 more than that, but you sometimes want to use a percent because people you get a better picture of it. You get a better picture when I say 50% of the people came than if I just said 7 people came, or even 7 out of 14. 50%, you get a better picture. You can see that half of that circle blacked out. So when you're dealing with percent problems, that's what you're always dealing with. They're trying to figure out, the whole is not 100. We have another whole. How many do we need out of our whole to be the same thing out of 100? So sometimes they'll say, he got 70%, and they want to know how many did he get right, if there were 20. Or they might say, they might tell you, he got 18 right. And they may ask you, how many out of 100 would that be? Or they might say, he got 20%, or it would be 20 out of 100 if he got 10 right. How many were in his whole? They could ask you any of those questions. When you're dealing with percent, it's always going to be one of those 3 things, because the percent is always over 100. That 100 is always going to be there, because we know that percent means out of 100. But we want to know our part out of our whole. Those are the 3 things you can look for in a percent problem. You're either going to be looking for the percent, you're going to be looking for the part, or you're going to be looking for the whole. Okay? Those are the only 3 things you can deal with in a percent problem. So that's the thing that you need to know when you see it's a percent problem. Your solution is, first, figuring out, what am I looking for? Am I looking for the percent? Am I looking for the part? Am I looking for the whole? Because only one thing can be missing. Only one thing can be missing. If I'm looking for the part, they have to give me the percent and the whole. If I'm looking for the percent, they have to give me the part and the whole. If I'm looking for the whole, they have to give me the percent and the part. Only one thing can be missing. Once you figure out what that one thing is, once you set it up, you're going to remember that the part over the whole is equal to the percent over 100. Okay? The part is always the is part of the sentence. So instead of part, you can remember is. And the whole is always represented with the of. And I'm going to give you some examples of that. So you can actually memorize is over of equals percent over 100. Now I have it set up this way because when it's set up this way, this is called a proportion. A proportion, each of these singly are called ratios. That's a ratio. That's a ratio. A ratio just shows the relationship of one number to another. There's a relationship between the part and the whole. There's a relationship between the percent and 100. These are called ratios. When we have two equal ratios, we have a proportion, okay? The good thing about ratios and proportion is that once you can set up a problem into a proportion, you can always get the right answer. Because what is always true with two equal proportions is that this number times this number gives you the same answer as this number times this number. Always. 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 If it is truly equal, this times this will equal this times this. The same as when you're reducing a fraction. You can always tell if it's reduced right if this times this is equal to this times this, because these are just equal fractions. When they say they're equal, what they mean is that they are proportionate. They are proportionate. They're not the same, but they're proportionate. Like 20 nickels is the same as $1. It's not the same thing, but it's the same. It's the same value, the same amount. It's saying that if you have 6 pieces out of something that's been cut into 12 pieces, it's the same